All right, welcome 8th graders. Today we're going to practice a little bit with Pythagorean Theorem continued from last week, focusing in on word problems actually, which again, kind of biggest thing is we can define what we're given and what type of a structure we need to use, if we need to write an equation, if we should draw a picture and approach it in that way. So we're going to practice a little bit in just reading the problems. We'll do one or two problems with Pythagorean theorem and how to identify what the question's asking and then just work through them. And I'm going to try doing this in a way that's efficient. So our first question is question 10 here. And you should be able to see this right up here. I'm going to try and get rid of this and simplify it a little bit. So the question's talking about a roofer that leans his 16-foot ladder against a house. And the question is saying if the base of the ladder is 5 feet from the house, how high up the house would that 16-foot ladder reach? So again, good pictures are instrumental with this. So the first thing I'm going to do is draw my house. Okay, we've got the house here. Let's just keep it basic and draw it as a square. Square house, pretty basic. We've got a 16-foot ladder that's leaning against that house. So we'll even draw the ground, and then we'll draw our 16-foot ladder. So here's the 16-foot ladder, and we're giving it a good label. It says the base of the ladder is 5 feet from the house. So again, we've got our right triangle that's constructed here. The base is 5 feet from the house. And the last part of the question says how high up that house would the ladder reach. So we're looking for one of the legs of the right triangle. We're looking for this length right here. All right. Now, when we look for that length, then we need to think about the fact that what's given is a right triangle. We know it's a right triangle because it creates a right angle with the house. And we're actually looking for one of the legs, which I'm going to title A. So we're looking for this distance. Well, Pythagorean's theorem states that a to the second power plus b to the second power is equal to c to the second power. So we essentially just need to know where to put all of our values and then do some basic math. So a is unknown. We're going to leave that as a squared. B is known. That's going to be this value here of 5 feet. So we'll go 5 to the second power. And c is also known. This is 16 to the second power. And after we kind of work this problem out, you guys are going to see that we can figure out exactly how high up that house this will reach. So we've got a squared plus 5 to the second, which is 25, is equal to 16 to the second power. And if you don't know 16 to the second power, we can calculate that. 16 times 16, punch it into my calculator to be exact, is 256. And now we just, again, go about solving it. A gets squared, then added by 25. Process for solving is to subtract 25 on each side. You can also use what's called the converse to the Pythagorean theorem with this one, but we'll just be thorough with this. 256 minus 25 is 231. And to solve for A here, take the square root of both sides. And that's going to tell us how high up the house this 16-foot ladder will reach. The square root of 231, thankfully for me, I've got my calculator. 231, square root of that is 15.198. So we'll round this up to about 15.2 feet. So again, given that house, we've got, maybe if we want to add the roof to the house, with a 16-foot ladder, we should be able to reach up about 15.2 feet. And again, the picture is the most important element of the problem. Okay, so that we know exactly what we're solving for. Let's try another example. So let's try this question 11. Kurt's building a rectangular deck. So the first thing I would want to do when I'm diagramming this is to actually draw a rectangle. The dimensions are 10 feet by 23. What's the length of the diagonal of the deck? So again, I'm going to take this. I'm going to draw a picture of my rectangular deck. The question itself tells me the dimensions are 10 by 23. So I'll put 23 feet here. I'll put 10 feet here. And then the question says, what's the length of the diagonal? So we're looking for that diagonal length, which I'll just show right here. We're looking for distance from here to here. Now in the scheme of the rectangle, we've got a little triangle that's formed, and it is a right triangle. And it feels like with this problem, we're looking for C. Okay, we're looking for this value. We're looking for the hypotenuse of that right triangle. Well, again, we're going to write down our formula. A squared plus B squared equals C squared. Fill in the values that we know. 10 to the second power, 23 to the second power is equal to C to the second power. Do the math with it. 10 squared is 100. 23 squared, don't have that one memorized. That's okay. 23 to the second power is 529 according to my calculator. Equals C squared. Add the two numbers together. That's 629 equals C squared. And to solve the problem, we take the square root of this side and the square root of that side. We get C is equal to the square root of 629. 629 square root would be 25.079. So we're going to round this to 25.1 feet. Right? That would make sense if this is 23 feet long and this is 10 feet long, that the C value should be roughly 25 feet long. That makes complete sense. All right, we're going to try just one more problem. Again, just example problems here. You're using the Pythagorean theorem kind of in more of a real world context. So we'll scroll this over. Ashley jogged 3.4 miles east, then 5.7 miles south. The question is, how far is she from her starting point? Well, let's draw a good picture. Let's say this is where Ashley is currently. She goes east. All right, I got to remember this. Never eat soggy waffles. North, east, south, west. So Ashley's going to go east for 3.4 miles. So 3.4 miles in this direction. And then south for 5.7 miles. So she's going to go down 5.7 miles south. Okay, put some units here. And the question is, in a straight line, how far is she from her starting point? So again, in this situation, we're looking for C. The right triangle that's formed is right here. Okay, we're asking in a straight line, how far is Ashley from her starting point? Well, your formula, which I'll pull this over now. Formula again will be A squared plus B squared equals C squared. We've got our A, which is a shorter distance or a leg of the right triangle. We've got B, 5.7. So we just need to simply do the math. 3.4 to the second power plus 5.7 to the second power is equal to C to the second power. Definitely something I'm going to want to use a calculator for. So 3.4 squared is 11.56. 5.7 squared is 32.49 equals C squared. We add the two numbers together, 11.56 plus 32.49, which again, I'm just doing on my calculator right now. Okay, I can even share that. Is equal to 44.05. One way, actually a quick way to raise something or to take the square root of something is to raise it to the half power. That's just a little trick for you guys if you wanted to use it. So it's the same thing, taking the square root and raising something to the half power or equivalent. So when we do that and we hit equals, we should get our answer of 6.637. So let's just round that. C would be equal to 6.6 miles from our starting position. 6.6. All right, guys, hopefully the video was helpful here today. Again, just kind of using the Pythagorean theorem in more of an application sense. Enjoy your practice.